Let's spend a few minutes talking about virtualization and virtual network components. But before we talk about what virtualization is and how it works, we first need to look at the way things have traditionally been done. In the traditional computing model, we have one operating system, or OS, installed on one hardware device. In this example, we have hardware that consists of our CPU, storage, and memory resources. We need an operating system to run these resources, which could be Windows, Linux, or even Mac OS. Either way, we have one hardware device being managed by one operating system. The operating system's role is to provide services for all the applications that run on the hardware device, so that they can utilize the memory, storage, and CPU resources efficiently. Here we have App 1, App 2, App 3, and App 4. Each app makes its own requests for hardware resources, and then the OS makes that happen. For example, let's suppose you're going to install a new server in your data center. The first thing you do is order your server hardware, and then you'd pick an operating system. When the server comes, you'd install a server operating system on the hardware. The operating system has full reign over all the resources available on the server hardware, including RAM, processor time, storage devices, network interfaces, and so on. Finally, you'd install applications on top of that operating system that would interact with system resources. There's a fundamental problem with doing things this way. It's terribly inefficient. Usually, applications that run on the OS don't fully utilize all the hardware resources all the time. This is often true on a server system, and you find out that a lot of times your computing resources are actually underutilized. For example, you may see your CPU utilization hovering around 10% most of the time. You may also see that your memory utilization is likewise hovering at around 20%. This means 80 to 90% capacity is still available to perform additional computing tasks. Servers are expensive, and wasted capacity means wasted dollars. Many times, servers are purchased for a specific purpose, such as running web servers for individual apps. This can lead to server sprawl for the many underutilized servers. This sucks up lots of power, puts out tons of heat, and costs an immense amount of money. But there's a way to overcome this and consolidate all those servers into just a few compact ones. That's where virtualization comes in. Virtualization enables you to run multiple servers on a single physical server, called a host, through hardware virtualization. When you do this, each independent operating system, or virtual machine, thinks it has all the hardware resources it needs and runs in its own little isolated container. So instead of the many underutilized servers in traditional networking, with virtualization, we can put many servers together on one hardware chassis to fully utilize CPU, RAM, disk, and network subsystems. Virtualization increases IT agility, allows for greater flexibility, delivers increased performance, and allows you to scale up quickly while enjoying significant cost savings. We'll get to some more important benefits in just a minute. Nowadays, we can virtualize just about anything: operating systems, storage, apps, networking, desktops, and more. Virtualization can also be enabled in the cloud, where much of the computing can be done remotely without you having to build and maintain your own data center. It also allows companies to build their own private clouds in their data centers to virtually deliver their homemade apps to their corporate users. Now, users can use just about any device to securely access their workloads remotely at any place, anytime, anywhere. The power of virtualization is driving an immense global and increasingly mobile workforce. Virtualization starts with you installing a thin piece of software called a hypervisor, which decouples the virtual machines, or VMs, from the hardware and dynamically allocates resources as the virtual machines request them. Once the hypervisor is installed, you can then create virtual machines with their own operating system and apps. Notice in this diagram, we have our memory, storage, and CPU just like before. But instead of installing an operating system directly onto the host, we install a hypervisor to manage it. On top of the hypervisor, we create virtual machines by allocating CPU, RAM, and storage. Generally, the more hardware you have on the host, the more virtual machines you can build. These physical servers that host multiple virtual machines have lots of processors and lots of RAM, and they're usually connected to an immense storage area network, or SAN, that's made to be fault tolerant. Notice that each VM has its own OS and applications in an isolated container. Each VM makes calls to use each piece of hardware, and the hypervisor facilitates those requests. You can install just about any OS inside of a VM and then run apps built for that OS. Before we go on, there are 3 kinds of hardware virtualization that you need to be familiar with. The first type is called full virtualization. In full virtualization, the virtual machine completely emulates a real physical host. This is good because it allows most operating systems and applications to run within that virtual machine without being modified in any way. The hypervisor fully decouples the operating system from the hardware. There are 2 types of full virtualization: bare metal hypervisors, type 1, and hosted hypervisors, type 2. We'll learn more about these in just a minute. Another form of virtualization is called partial virtualization. In partial virtualization, some virtual machine components are virtualized while others aren't. In other words, the OS uses some virtual components and some physical components while it runs. It's important to note that an operating system can only run in a partial virtualization environment if that operating system has been specifically modified to do so. The last type of virtualization is called paravirtualization. In paravirtualization, the hardware isn't virtualized at all. In other words, all the guest operating systems running on the hypervisor actually access various hardware resources in the physical devices directly. It doesn't virtualize any of the components. To do this, the guest operating systems run in isolated domains on the same physical hardware, which basically simulates running on separate systems. For an operating system to run on a paravirtualization environment, it must be specifically modified to do so. As you can see, a hypervisor is a fundamental component in any virtualization implementation. There are several different hypervisors that you can choose from, and they generally fall within 2 main categories, type 1 and type 2. As we mentioned, type 1 hypervisors are installed directly onto the hardware and allow you to build VMs. This type is used in data centers to virtualize servers. Examples of type 1 hypervisors include VMware vSphere, Microsoft Hyper-V, Linux KVM, Citrix Hypervisor, Xen, and Oracle VM. These are enterprise-class hypervisors for serious, large-scale virtualization deployments that provide an array of management tools and feature-rich benefits. Alternatively, we have type 2 hypervisors. Since type 2 hypervisors are hosted and run on top of a regular operating system, they allow you to get a test environment up and running quickly without having to buy huge systems. Examples of type 2 hypervisors are VMware Workstation, Oracle VirtualBox, and Microsoft Hyper-V, which is built into Windows 8.1 and 10. All these hypervisors perform basically the same role that we talked about before. They allow you to install multiple operating systems on a single physical server. There are many benefits to implementing virtualization in your environment. The biggest drivers are reduced expenses and increased return on investment. Most virtualization platforms provide redundancy and load balancing, which minimize downtime. Also, unlike traditional computing where you have to go out and buy a physical server, you can spin up a virtual server in a fraction of the time. You can also take server snapshots in case you need to make a server rollback. An entire VM is stored in just a few files, and they can easily be copied or moved as you would any file. Finally, virtualization makes IT tasks much easier to manage and less costly. With benefits like these, you can see why nearly all companies are using some form of virtualization in their business today. That's it for this lesson. In this lesson, you are introduced to virtualization's common roles and functions. We discussed how virtualization works, different virtualization types, the hypervisors you can use, and virtualization benefits.